All right, part 2 of our speed, velocity, acceleration lab stuff. So you're going to do an acceleration mini lab. What is the acceleration of a car that travels down a ramp and eventually stops? You're going to make a prediction on this using an if-then statement to make a hypothesis. Now keep in mind, acceleration of most solid falling objects is around 9.8 meters per second squared. So that's gravity. You need to decide how the acceleration of the car on the ramp is going to relate to that. Set up a ramp using 5 books. You're going to measure out a meter from the end of the ramp. So once you have your ramp set up, you're going to measure a meter beyond that and mark the 50 centimeter and then the 100 centimeter distances. Then you're going to measure the total distance from the top of the ramp down to the 100 centimeters after the ramp. You're going to have 3 people with stopwatches and 1 person in charge of releasing the toy car. 1 person's going to be at the end of the ramp doing the time, 1 person at the end of the 50 centimeter tape, and 1 at the 100 centimeter. On a count of 3, have all 3 timers begin and the car release from the top of the ramp. Record the time that it took the car to reach the end of the ramp, the 50 centimeters, and the 100 centimeters. Then you're going to repeat that steps 4 and 5 2 more times to get 3 total trials. And then you're going to calculate your average times. Once you get your average time, you're going to calculate the velocity of the car at the beginning of the ramp. Your hint is that it's sitting still. At the end of the ramp, 50 centimeters and 100 centimeters. Then you're going to graph the velocities of the car at each of the 4 parts of the ramp system in a line. So keep in mind, your top of the ramp is 0. Your end of the ramp is whatever you measured it to be. At this location, the 50 centimeters after, you need to include the end of the ramp. And the 100 centimeters after, you also need to include the distance of the ramp. Then you'll have your average times brought down here. And then you're going to calculate your velocity based on that. Then you'll go ahead and graph the velocities of the car at the 4 parts of the ramp system. So each of these and their velocities. So you'll have the distances and the velocities. So distance should be, your independent variable is your distance, and then your dependent is what you measure and calculate. Then you'll have 3 questions here where you're going to calculate and explain, and then you can carry on to this here where you're going to review, match up graphs 1 through 4 with the correct description of the motion of the object for section 1, and then use the section 2 graph to complete questions 5 through 7. So these, you're going to decide how that fits with these here. And then you're going to use this part with the A, B, and C for 5 through 7 here. Okay? And that's it for that part.